Right, okay, here we're going to do this 2022 paper. This is my third time attempting to do it without mistakes. Right, so we have here the pituitary gland. Right, for now, that produces antidiuretic hormone. This is called the thyroid gland. I'm going to stop putting gland. It produces thyroxine. I hope I've spelled that right. Let's have a look. Yes, it does have an E. Okay. You have here the pancreas. That's that one there. And that produces something called for now insulin and glycogen. Right. Adrenal glands, yeah. They produce something called adrenaline. Right, then you have females have ovaries and males have testes. Ovaries produce estrogen and progesterone. The testes produce something called testosterone. Okay, the two questions are quite straightforward. Which gland produces insulin? That's A. Which gland produces progesterone? That's D. Done. Right, we are now on question B. Right, it's a maths question. We're comparing these two parts, yeah? So we're comparing 420 centimeters per minute versus 55 meters per second. Now we can convert meters per minute into meters per second. So we do 420 divided by 100 gives 4.2. And then we do 4.2 divided by 60 to give 0.07 meters per second. Now if you look, that's in meters per second and that's in meters per second, so we can do a direct comparison. So I can write nerves versus nerves to hormonal. It is 55. I wrote it the wrong way around last time, that's why I'm re-recording this. 55 to 0.07, and then we need this to be 1, so we divide by 0.07 and we get 1, and we divide this by 0.07 and we get 786.1. There you go. So the answer is 786.1 to 1. Where did I get 786.1 from? Right, I'm being silly. I'm being facetious. Whatever that means. Right, done. So we're going to write 786 to 1. Let's move on. Right, this is a standard answer. Differences between nerves and hormones. Standard answer. One's impulses, one travels in the blood, one is short-lived. 3 other. Ooh. Right, speed. Okay, so they've done speed. So we need to write nerves, nervous system or nerves uses impulses, electrical impulses, yeah. 1 second. Right, I will emphasize this. It says ignore impulses, so whenever you're writing it, write electrical impulses. Right, nerves travel along neurons or neurons, yeah. They use cells as opposed to travel in the blood. They go to they target specific cells. They don't travel all over the body in the bloodstream. They've said they're quick and they are short duration or short-lived. Yeah, sure. Duration is short. Duration is short. They are very short-lived. They don't have a long-lasting effect. Done. Let's move on. Right. These sort of questions, you can end up with loads of easy marks, or if you ain't got a clue, then you'll be stuck. Fungi do not carry out photosynthesis. Their body is usually organized into mycelium made from thread-like structures called hyphae. Hyphae. You're gonna have to read up on this, and I've not got the book in front of me, so I can't give you the page number. Fungal cell walls are made of chitin or chitin. Fungi feed by extracellular secretion of enzymes onto food material and absorption of the organic product. This is known as saprotrophic nutrition. So this, it looks like they've drilled down onto other mechanisms supposed to humans, how the humans feed or animals feed or mammals feed. So what they're saying is they're widening everything, so you've got to make sure you know all the topics. If you want a top grade, start reading. Student investigates the effect of temperature on the rate of metabolic respiration of use. Students measure the rate of gas produced per minute. So have you noticed as the temperature is going up, the rate of gas production goes up to this point. This point, right, is called the optimum temperature. This is good to know. Right, these words. After that, the rate of respiration goes down because the enzymes denature. Right, they need denature, they stop working properly. The active, oh, there's your enzyme like Pac-Man, yeah. That there is the shape of the active site. The raw materials are called substrate. That fits in there nicely. It reacts and then releases the product and they disappear. Now, what happens is if I use too much of a high temperature, the active site changes. So now the substrate won't fit, so the substrate here will not fit, or it won't fit properly, so it takes longer for the reaction to take place. So you've got to know, look, optimum temperature, enzymes denature. Over here there's less kinetic energy, so the reaction's too slow. So you always look for the optimum temperature. In human beings it's around 37 degrees. Let's move on. Right, the gas produced when anaerobic respiration is carbon dioxide, CO2. Right, okay. Increasing temperature. So increasing, use another color, increasing temperature increases the kinetic energy, so you have more success. So why can't I spell? Successful collisions per unit time. So you have more successful collisions per unit time. Right. Up to an optimum temperature. Up to an optimum temperature. Then the enzymes denature. Right, because the active site changes. So look, increasing kinetic energy, so you have more successful collisions per unit time, up to an optimum temperature. Then after that, they denature and respiration goes down. How can you measure? Again, this is a standard answer, right? How can you measure? It's a the rate of gas production. What you can do is, what did they do? Gas produced. Okay. How? It's asking you how it could, yeah. Use a gas syringe to measure the volume of gas produced. And did it say per minute? In 1 minute? Okay, yeah, just per minute. So they're measuring it over a minute. They've already got a stop clock. That's fine. We'll live with that. Right. Vital lung capacity. Yeah, we got time. Right. Vital capacity is the maximum volume of air forced in one breath. And age for a large number of people. So as age goes up, your vital capacity is, I don't know, in its 20s, and then it starts going downhill. Right. Right. What is meant by the term medium? Oh, that's interesting. Not seen that one in a maths, in a biology paper. Normally you see it in maths. So it is the middle value in an ordered list. Yep. It's the middle value. Oh, how do you spell value? Well, let's write it. Come on then. Value. Give one reason why the median is used rather than the mean. The mean used has a wide range. The median used as each age has a wide range. Okay. The median is used, this is how you word it. The median is used since each age has a wide range. So since the age has a wide range, yeah, each age has its own. So median depends, isn't it? You also remove any outliers or anomalous results. Describe the relationship between, right, there's 2 marks between age and shown. So have you noticed the capacity, where is it? Vital capacity increases rapidly up to the age of 20, and then from 20 to 80 it decreases, right? There's a right, you've got rapid change, and then it decreases slightly from here to here. Yeah, so you've got a rapid change in the first 25 years, well, 25 years, and then over the next 55 years it goes down gradually. Now we need to put that in words. That was easy saying. Right, let's get that. Right, vital capacity increases up to the age of just 20, 25, 20, 25, whatever you want to say. Describe, it's not saying explain. Right, okay, so this is the describe part, yeah? It then levels off between 20 and 25 years. And then from the age of 25 to 80, it decreases steadily. Yeah, okay. Explain why. The lung capacity, or the the lung capacity continues to grow. The lung capacity continues to grow up to 20. Well, I think slightly more, but then there is little change there's little change and because you stop growing, because little change due to growth stopping. There's no more capacity unless you train, and then unless you exercise the muscles, intercostal muscles, diaphragm, the muscles, and diaphragm. That's how I remember it. Diaphragm weakens over time. Weakens due to age, just over time. That's it. You've got them 3 points. Age is not the only variable that can change disease, infection, lifestyle choices, and the most obvious one is smoking. That reduces the lung capacity. You could have lung disease, you could have pollution, you can have pregnancy, you can have altitude, as in the area you live in, smoking, and we'll say gender or sex or gender. Okay. Describe a method you could use to demonstrate the effect of exercise on breathing rate in students. Ooh, right, okay. It's not quite a comms one, but first thing you do is the effect of exercise. So what you do is measure breaths per minute before exercise. Right, first of all, select, just say in students, select 20 students. So you've got more than one. So you can remove anomalies, yeah? Select 20 students. Measure the breaths per minute before exercise. Give all of them the same exercise and measure the breaths per minute after. Right. Right. What you do is remove any anomalies and average out. Because look, here what you've done is, that's the repeat part. Here's the remove any anomalies and average out, yeah? Here's the breaths per minute before, and here's the breaths per minute after. And what you're doing is you keep give them all the same exercise to try to keep it fair. Right, okay, so what you could do is you could expand on this. You could say same type of exercise. You can for the same time. Okay, you could use the same sex or gender, age, fitness. Right. Right, okay. 3 questions is more than enough on this one. We'll do the others on another video.